Good morning, geometers. This morning I will quickly review 12.1 and then we will go over 12.7 through 12.10, what you did for your homework. Alright, you need your book out, your notepad, and your writing utensil. Are you ready? Good. First, quickly, 12.1. In 12.1, we discussed how angles which start from the origin of a circle and have and inscribe a little arc will be equal to each other. So that's 60, and this arc is also 60. Similarly, if I have an inscribed angle, which is an angle on the circle, which covers the same arc segment of 60 degrees, the angle here will be 1/2 of the angle from the origin point, 30 degrees, which is half of 60. This rule holds even for obtuse angles. So if I have this angle, which is obtuse, as 270 degrees, I have an angle from here to here. This will be 1/2 of 270, 135. Alright, so you remember that, and that is not too bad. Let's move over to 12.7. Okay. In this problem, we are asked to find AEB, given that arc AB is 40 and arc DC is 80. Alright, what's our first step? Now our first step should be to make a line so that we have angles whose measure we know. Okay, can you draw a line so that we have an angle whose measure we know? We don't know the measure of DEC, here's E, because E is not the origin of the circle. But if I connect A to D, I can find CAD. I know it because I know that arc DC is 80 degrees. So what's angle CAD? It is 40. Good. You guessed it. We're supposed to find AEB. Does this help us at all? And we know ADB because it also inscribes this arc. So we have an arc inscribed here, and an arc here. This arc gives us 40, this arc will give us 20, and this arc, and that will give us the remainder, 60, that's total 180, so this is 120. This is a straight line, so we know that this is 60. And that's our answer. AEB is 60 degrees. You see how I did that? The basic insight. The basic insight was saying that once we draw this line, I can find this angle and this angle because we have these arcs. Alright? When we abstract out from problem 12.7, we can see a general solution. On this next problem, 12.8, it's the same as the previous problem, except we put a y for 40 and an x for 80. And it's still quite simple. So, I draw my line from P to Q, and I know that PQS is 1/2 of y. And I know that QPR is 1/2 of x. What's my next step? We want to solve for QTR. What is QTR? Well, you notice that angle QTR should be angle PQT plus angle QPT. So add this and this, I should get this exterior angle. So, back to the writing. X over 2 plus y over 2 equals QTR. And x over 2 is the same thing as saying 1/2 times x. As you should know, these are equivalently the same. Now, why does this little step work? This angle is these two angles combined. And we saw this in chapter 3 of the book. The exterior angle of a triangle is equal to the two opposite angles of that triangle. Now, that's a really long time ago, but that's what's being used here. Something from chapter 3. And so this gives us a general rule. That is, that the measure of the angle formed by two intersecting chords is the average of the measures of the arcs intersected by the chords. So if we were to go up here, 40 and 80, their average is 60. So that's what this angle is, 60 degrees on both sides. That's 60 and that's 60. 40 plus 80 over 2 is 120 over 2, which is 60. And if you're good with taking averages, you can do it in your head. Behold, my people, we will now have an angle outside of the triangle. And we know that the arc of DE is 110 degrees, and the arc of BC is 20 degrees. So let me draw that in, 20 degrees. All right, so what can we do? What can we say? What should be our first step? Come on, you know this. It's the same first step that I did in 12.8 or 12.7. Draw a line so that we have an angle whose measure we do know. Let's do it from angle D. Whoops, that was ugly. So you see, we know what DBE is. What is it? Say it out loud. I know I can't hear you. Say it out loud anyway. That's right, 55 degrees. Good. And what's angle BDC? Excellent, it's 10 degrees. So we have everything we need because we have a triangle here. What is angle BAD? Well, you know what you can use? You can use that rule I talked about, the rule of exterior angles of a triangle. 10 plus this should be 55. So this is 45. There we have it, 45 degrees. And then we just need the general formula. And that's what problem 12.10 is, the general formula that shows this to be true. Lastly is 12.10, which is just the general form of 12.9, where the idea is if we know what arc XV is, let's call it B, and we know what arc YW is, we'll call it A, we can find angle Z. We don't need any other information, we just need these two measures. Alright, and so how do we do it? Well, we see that x, y, v equals b divided by 2. And we see that yvw equals a divided by 2. And then what is angle z? Well, by the same law of triangles, that the exterior angle must equal the sum of the interior angles, we know that xyv equals angle z plus a over 2. And then we can just rearrange that to be, let me write that out for you first, xyv equals angle z plus a over 2. And then to rearrange that, let's rename this b over 2, as we did above. To rearrange that, b over 2 minus a over 2 equals angle z. And that's the general formula. b minus a over 2 equals angle z. So knowing these relationships, the two relationships that we have discovered in this chapter, we'll be able to do all of the problems in this section. All right, thanks for joining me. Let me know if you have any questions. My office hours are 9 to 10. I really want people to show up, call in, ask questions. Otherwise, I'm going to be bored out of my mind, and I would love to help you. Thank you. God bless.